Hi there. During this session I'm going to go over the basic motion calculations. So I'll explain the terms distance, displacement, speed, velocity and acceleration. Start off with speed. So what we have here is speed is the rate of change of distance, or the distance covered per unit time. It can be calculated by speed equals distance divided by time, where speed is measured in meters per second, distance in meters, time in seconds. And for those of you who need a little bit of extra help, you can always use a calculation triangle. So this helps us because whatever the unknown value is, if we're answering a question, we can work out by covering up, let's say, speed, and it will tell us that to do distance divided by time. If the question asks for distance and gives us speed and time, we cover up distance, and remember that's going to be speed times time equals distance. Now, there's terms distance and displacement. Distance is what was used in the calculation for speed, and that involves the distance covered on a journey. Doesn't matter if it's a straight line or long curvy line, it's the total distance travelled. So here my ant walks in a roundabout way 8 meters total distance. Now that's his distance, but his displacement is only 5 meters to the east. Displacement is the direct, as the crow flies, length from one location to another location with a direction. So displacement is a vector. Now the reason I introduce distance and displacement is because displacement is used in the calculation of velocity. So velocity equals displacement divided by time. So as displacement is a vector, then velocity is also a vector with the units meters per second. Now we'll notice this has the same units as speed. Velocity and speed, if you're travelling a straight line, can often be interchangeable. You've got to remember that it is a vector, so therefore it must have a direction to be fully fulfill its requirement. So we've got velocity and displacement are used to define there. I should also mention something called instantaneous velocity. Now we're going to look at graphs in the future, but just for now the instantaneous velocity is a velocity at one instant in time. So this is a displacement time graph. And what we have is the instantaneous velocity takes us for the gradient at that one moment of time where that tangential line meets the line showing displacement in time. So here we're going to have a velocity equals change in displacement divided by change in time, where time is tending towards 0. That's the general idea. So often if you have an object which is changing velocity, you can find out what the velocity is at one moment in time, one which you describe. Acceleration is the rate of change of velocity in a given direction. So what we have here, again, it's in a given direction because it is a vector. It stems from a calculation of rate of change of velocity, and velocity is also a vector. We work this out by looking at the change in velocity divided by time. Now, velocity or change in velocity is often calculated using some terms which we're going to be very familiar with. Change in velocity is meters per second, but sometimes it's shown as the initial velocity minus and the final velocity. So change in velocity is final velocity minus initial velocity, and that gives us that change. This term v for final velocity and u for initial velocity we're going to continue to use through the course in some more advanced situations. And obviously time is measured in seconds. Couple of my one note here is that if an object speeds up or slows down, it is obviously accelerating, but also if it changes direction, that means its velocity is still changing, so that also needs to be considered as accelerating motion. A couple of questions here just to finish you off. A bike starts from rest and accelerates to 30 meters per second over 6 seconds. what is the acceleration of the bike? Think about it, do your calculations. You should come up with an acceleration of 5 meters per second squared, and a car deaccelerates from 70 to 20 meters per second at a rate of minus 5 meters per second squared. So see, we're showing deacceleration as acceleration with a negative sign here. How long does this car deaccelerate for? Or in this case, we've got 20 minus 70, which gives us minus 50, divided by the acceleration, which is minus 5, and that gives me a value of 10 seconds. So there's a very quick introduction to the basic ideas about motion.